Hey, this is Mr. Mola for lesson 2-4, solving multi-step inequalities. So this is going to be very similar to solving multi-step equations. If you remember, in multi-step equation, there's really one trick, and it doesn't even come up on this example problem, so we'll have to see if it comes up on the homework. So remember, when we're solving multi-step equations, usually our first step is to add or subtract, and then we want to multiply or divide. So here I have 3x minus 2. So I'm going to add 2 to both sides. So then I'm left with 3x is less than 10 plus 2 is 12. So that says 3 times x. So I'm going to end up dividing by 3. So 3 divided by 3 cancel. 12 divided by 3 is 4. So I'm left with x is less than 4. And then same thing for graphing. Since it's just a less than sign and not an equal to sign, I'm going to have an open circle at 4. And I'm going to go to the left because those are numbers less than 4, like 3, 2, 1, 0. All right, here I got 4a plus 8 is greater than or equal to 0. So same thing, I'm looking to add or subtract first, so I'm going to subtract 8 from each side. So 8 minus 8 cancels. So I'm left with 4a is greater than or equal to negative 8. Same thing, it's 4 times a. So I'm going to end up dividing by 4. So I get a is greater than or equal to negative 2. Don't have to flip our sign there because I divided by a positive 4, not a negative 4. So we're all good there. It is a greater than or equal to sign. So since it's an equal to, I'm going to fill in that circle. And numbers greater than negative 2 go to the right, like negative 1 and 0 and all those positive numbers there. All right, 3 and 4 might be the ones that look tricky, but remember the whole thing is not over negative 3 here. So it's not, if it was written like this, then our first step would be to multiply by negative 3, but it's not. So we don't have to worry about that. So if you remember those tricky ones from when we did this for equations. So first step, still looking to add or subtract. So I'm going to subtract 2 from each side, subtract 2. So then I get b over negative 3 is less than or equal to 3 minus 2 is 1. So then I have b divided by a negative 3, so I'm going to multiply by a negative 3, multiply by a negative 3. And here, since I multiplied by a negative 3, my sign ends up getting flipped. So it was a less than or equal to sign, and I'm going to flip it to a greater than or equal to sign. And then 1 times negative 3 is negative 3. So since it's a greater than or equal to, I'm going to put in a filled in circle there. The numbers greater than or equal to negative 3 go to the right, like negative 2, negative 1, 0, and those positive numbers. All right, 4 looks exactly the same. So negative c over 2 minus 6 is greater than negative 8. So I'm going to end up adding 6 to both sides. So then I end up with negative c over 2 is greater than negative 2. I'm going to end up, since it says divide by 2, I'm going to multiply by a negative 2 to get rid of that negative sign. So now I'm left with c. I multiplied by a negative 2, so I'm going to flip that greater than sign to a less than sign. And then negative 2 times negative 2 is a positive 4. So open circle because it's not equal to, and numbers less than 4 go to the left like 3, 2, 1, 0, all those negative numbers. 5, we got 2 ways we can do 5. So 8 is less than or equal to negative 4, and then parentheses d plus 1. So since this is a nice number here, and by nice I mean 8 can go into 4 and 4 can go into 8. So I'm going to do that first. Otherwise, I could distribute here, but that ends up being more steps, so I don't want to do that. So this says negative 4 times d plus 1. So I'm going to divide both sides by negative 4. So then I end up with 8 divided by negative 4 is 2. And then since I divided by a negative, my sign's going to end up getting flipped. So I'm going to flip that to a greater than sign. Sorry, it's negative 2. And then I still have the d plus 1 over there. It's a plus 1, so I'm going to end up minusing 1. So I end up with negative 3 is greater than or equal to d. Again, I don't like it when my d is written back, or my problems are written backwards. So I'm going to flip that. So d is less than or equal to negative 3. Again, you don't have to do that last part. That's just something. I don't like it when the number's first. So I'm going to fill in my dot here because it's an equal to. The numbers less than -3 go to the left. So like -4, -5. So you could have either, going back to the first step, I could have either divided by -4, or I could have distributed and gotten this. And I still end up with the same answer because I'm going to -4 here. Whoops, never mind, I'm going to add 4 there because it already is a -4. And then once I divide, I still end up with -3 is greater than D. So either way you want to do it there, both ways work. All right. For here, only difference is we got a variable on both sides now. So we're going to have to get those together. So now we're going to have 2 steps of adding or subtracting here. Okay. And remember, I always like to do this to where my positive, so that I get a positive variable. So it's not wrong to add 2n to each side. I'm not going to mark that wrong. But I like to do it where I get my variables together first, and I like them to be positive. I'm going to add 4n to each side. So now I'm left with 5 minus -2 plus 4 is 2n. And that's greater than 8. Then I got to get my numbers together. So subtracting 5. So I get -2n is greater than 3. Then divide by -2. Divide by -2. So I get n. I divide it by a negative. So flip my sign from a greater than sign to a less than sign. And I can't simplify that, so I'm just going to leave it as -3 over 2. Okay. 7, 8, and 9. You'll see there's a little bit of a trick here. See how fast we can spot it. So same thing, I'm going to get my variables together. So I'm going to subtract 6h from each side, subtract 6h, and you'll see something happens. My variables end up canceling out. So I'm left with -18 is less than 1. So now we come back into the many solutions or no solutions. So with these, it's a little easier to tell than it was last chapter. You're basically saying if it's true or false. Is -18 less than 1? And that is true. And when something's true, that means it is infinitely many solutions. If you get something that's false, then it's going to be a no solutions one. All right, so let's look at this one here. So same thing. I want my variable to be positive. It's not wrong if it's negative. I just like it easier that way. So I'm going to add 4p to this side. So if I add 4p, I get 7p plus 4 is greater than or equal to 25. It's a plus 4, so I'm going to subtract 4. So I'm left with 7p is greater than or equal to 21. Divide both sides by 7. And get p is greater than or equal to 3. All right. Now let's look at another many solution or no solution problem. So you'll see here, we also got some simplifying to do. So 7j minus 4j is 3j. And you'll see we have a 3j on the other side too. So we're going to end up canceling out those 3j's. Subtract 3j from each side, cancels out. So I'm left with 6 is less than -2. And that is not true. 6 is not less than -2. So this one is false. And we would say that that is a no solution. Okay. This one, kind of the same thing, except now it's just fractions. 12 times a fourth is 3. 12 times 3 is 36. 3 times w is 3w. 3 times 4 is -12. Same thing, I'm going to get this to cancel out here. So subtract 3w from each side. W's are all gone. So I'm left with 36 is less than or equal to -12. 36 is not less than -12. It's greater than, so another one that's false. And another no solution. All right, 11. You had one of these like on your test last time. So find the value for k for which a solution of the inequality is all real numbers. All right, so here, let's figure out what k needs to be to make it all real numbers. Okay, this one's going to be kind of tough because I got that k on the outside. But remember, we're kind of looking for 12 r's on both sides. So this side already has negative 12r, sorry. So I need to make the left side have a negative 12r. Well, I already have a 4r here, so what does k need to be in order for me to have a negative 12r on the other side? And so the answer is going to be, it needs to be a negative 3. So kind of some deductive reasoning there. I know I need them to be both a negative 12r on both sides, so I need to put in a negative 3 there. I'll kind of show you how that works out then. Negative 3 times positive 4 is negative 12. Negative 3 times negative 5 is a positive 15. And so there we go. Our r's are going to end up canceling. And so I'm left with 15 is greater than negative 9. And that is true. 15 is greater than negative 9. So we have our answer is true, and it is infinitely many solutions.